to learn about direct variation. When two variables are related in such a way that the ratio of their values always remains the same, then they are in direct variation. Now, let's say we have two variables. X and Y. Let's say X is always twice as much as Y. So X is equal to 2Y. Now, here, if Y increases, then X also increases. But after the increase, X is still going to be twice as much as Y. Let's see if this is true. If Y is equal to 1, then X is equal to 2 times 1, which is equal to 2. If here 2 is twice as much as 1, and Y is 1. If Y is equal to 2, then X is equal to 2 times 2, which is equal to 4. Here, 4 is twice as much as 2, and 2 times 2 is equal to 4, and Y is 2. If Y is equal to 3, then X is equal to 2 times 3, which is equal to 6. Here, 6 is twice as much as 3, and Y is equal to 3. Now, in all these examples, X is twice as much as Y. 2 is twice as much as 1, 4 is twice as much as 2, and 6 is twice as much as 3. Let's find the ratio of X to Y, or the fraction of X over Y. X over Y is equal to 2 over 1, 2 over 1, which is equal to 2. X over Y is equal to 4 over 2, 4 over 2, which is equal to 2. X over Y is equal to 6 over 3. 6 over 3, which is equal to 2. Here, 2 is always the constant value of X over Y. For all these examples, the constant value of X over Y is equal to 2, 2, and 2. Now, we can say that X over Y will always have the same numerical value or constant. In our case, it is 2. Now, X over Y is equal to K. This means if X varies directly as Y, we can say that X is equal to K which x changes. If y varies directly as x, we can say that y is equal to kx. K is the constant or the rate at which y changes. Let's look at a real-life example. 1 gallon of milk costs $3. How much does 10 gallons of milk cost? 10 gallons of milk costs because $3 is how much it costs to buy 1 gallon times 10, because we are trying to find out how much does 10 gallons cost, and we get $30. Now, let's write the ratio of the cost of the gallon to the number of gallons, because we are finding out the direct variation of the cost of the gallons to the number of gallons. So the cost of the gallons to the number of gallons is equal to 3 to 1. Here, if the number of gallons increases, then the purchase or the cost of the number of gallons also increases. But after the increase, the cost will always be 3 times as much as the number of gallons. Let's see if this is true. When we buy 1 gallon, let's write this in a different color. When we buy 1 gallon, it costs $3. Now, let's write this $3 in the fraction of C over G, cost over gallon. C over G is equal to cost $3 over gallons, 1 gallon, which is equal to 3. For 2 gallons, it costs 3 times 2. Let's write this a bit lower. For 2 gallons, it costs $3, because that is how much it costs to buy 1 gallon, times 2, because that is the number of gallons we are buying, and we get $6. Now let's write 2 gallons and $6 in the fraction of cost over gallons. So cost over gallons is equal to cost $6 over the number of gallons, 2 gallons, which is equal to 3 over 1, which is equal to 3. Well, this is actually 2C over 2G, because we have twice as much the cost, because we have twice as much the number of gallons. So 2C over 2G. So we can say that C over G is equal to 2C over 2G, which would then become equal to 3C over 3G. etc. Now, in this number sentence, if you know 3 of the numbers, like if you know C, G, and 2C, you can always find the fourth number using cross multiplication. The fourth number would be 2G. Today we learned about direct variation. Thank you for watching this video.